When designing charts, designers often need to choose what colors to use. Color Brewer is one of the go-to tools for selecting sequential color maps. Color gradients can also be manually created using Photoshop or visualization domain-specific tools like CCC tool. Sequential color maps can vary widely, but they are judged according to some universal criteria. For example, the traditional rainbow color map is often not highly valued since color maps need to be smooth to avoid illusions such as hue banding. Sequential color maps also must follow lightness monotonicity. So among this assortment of color maps, these would be sequential color maps. What's left after color hue and saturation variants are removed are gradients from black to white. Another rule is that they should be perceptually uniform. Color maps are discretely sampled RGB points along a mathematical curve, and whether it comprises 10 or 256 colors, uniformity states that each consecutive pair of colors across the palette should look similarly different from each other. Yet another rule is that they should have discriminative power. There's a reason other than being pretty that color maps are, well, colorful. For example, because the color map viridis traverses a large area of the color space, it can reveal more variance in data than a straight line black to white color map. That being said, people obviously do pay attention to the aesthetics of color maps, whether that is due to color preferences or color harmony. The semantic meaning of a color can also actually influence our judgments about data. And if you are a data scientist for an organization, you may want to include colors that portray a brand or ones that your audience will be familiar with. Of course, all of this is a bit too much to think about for a normal person. So usually people ignore all that. They type this line of code and you might just get a reasonable chart like this one. But ultimately, the default options are simply default options and may not fulfill an analyst's specific needs. Recently, tools have leveraged existing expert-crafted color maps to help people design new ones more efficiently. For example, Color Crafter and Color Moves. Using Color Moves, users can drag and drop piecewise segments of the existing color maps to construct new ones. However, these tools have limitations. The outputs of Color Crafter are limited because their algorithm clusters existing color maps to only 9 model structures, and while Color Moves is more expressive in theory, it still requires the manipulation of colors using a Photoshop-like interface. The idea behind our tool, Cieran, is that if the color space is just a 3-dimensional space and color maps are trajectories across that space, then is there a way to generate new color maps the same way that we might teach a robot how to explore its environment? One proven and effective way for a human to easily teach a robot how to move is through inverse reinforcement learning, where the human can give a robot agent both demonstrations and feedback about how to act in the environment. So we already have an environment and expert demonstrations in the form of pre-designed color maps scattered across the internet. What can we include here so that a color map generation tool can recommend color maps that addresses a user's needs? Cieran leverages a human feedback mechanism called preference learning, where the system cores a user for pairwise choices across the example color maps. So instead, using tools like Photoshop, all the user has to do is say, I like this better than this one, and input 10 to 15 choices to the system, as demonstrated here. Ultimately, what our tool learns is a model of a color map's utility defined in terms of the color map's features. A color map is defined by 9 features according to Cieran. our tool might see the Viridis color map as something like this. So each parameter distance is the distance from the color map to each corner of the color space, indicating preference towards certain color hues. And whilst the chroma inclination value M indicates how much the color map will vary in saturation across as it traverses the above trajectory. For example, Viridis will be recommended by the tool when setting data 1, 2, 3 to -0.5, indicating a preference for a color map that goes through greenish yellow tones, and whilst also inputting a teal blue seed color. So after modeling user preferences as a function of color map features, we can use this to generate new color maps using reinforcement learning. While as a bonus, we can all rank existing color maps with respect to their aesthetic utility. The final feature of the tool is using a slider to select the right color map, where all new and existing color maps are sorted according to their utility. We conducted a user study to mainly answer the question of whether Cieran effectively models preferences from a few user choice inputs. Each participant designed a color map for one of these two-dimensional histograms, and they were asked at each trial to respond to the question, which is better for a paper figure? Each participant was a researcher in physical or social sciences with data analysis experience with scripting tools such as Python. We had 12 participants where each person iteratively input 15 choices. Then they were asked to rank 4 color maps, which were the new color map generated by the reinforcement learning algorithm, the top ranked existing color map, the median ranked color map, and the last ranked color map. So what we're doing here is instead of the study participant choosing the final color map using a slider, we are simply obtaining 4 samples from that ordered list, asking people to manually rank them, and seeing if the user ranking correlates with the system's ranking. Here, we visualize the raw tally of all the votes from the participants. What we found was that both the new and top-ranked color maps were ranked higher than others in aggregate. And as a metaphor, if this was a ranked choice voting election, for instance, the new and top-ranked color maps are essentially going into a runoff. So these findings do suggest that Cieran efficiently modeled user preferences and was able to generate high-performing novel color maps.